Hey boys and girls, so I'm in my dungeon, I call it, the man cave, the basement, the cellar of my house. So I just want to introduce to you our next target. Our next target is really discovering why we get seasons. Some of you have already learned this already based on what I've seen come from you in terms of work. But our next target really is looking at, why do we seasons, or how do we have seasons? When I say that, in the summer we obviously recognize that we get more daylight, it's warmer. In the winter we get less daylight, it's colder, and really we want to figure out why that is. So I'm throwing this video together to kind of introduce that idea. Next week we'll be doing an HMH study, an ed puzzle, and of course some sort of assessment that you'll be showing me what you know in terms of seasons. So I had this really awesome light demonstration that I normally do in class with a globe and a spotlight, but as you can see, it's really hard to figure this out. So we're going to have to use some different strategies here. But really what you're going to find out in today's study and in the next week is that we don't get seasons because of our distance from the earth to the sun. Actually, we're further away from the sun during our summer than we are in our winter, believe it or not. So the distance between the sun and the earth really has nothing to do with seasons. It's all about the earth's tilt. So we know that the earth is tilted at 23.5 degrees on its axis. And that's why whenever you see a globe, it is tilted. It's not straight up and down. There are some planets that are straight up and down, but the earth just happens to be 23.5 degrees tilted on its axis. And that gives us our seasons. So here I'm going to do a quick demonstration about light and the main reason we get seasons. Remember, the main reason we get seasons isn't because of the distance between the earth and the sun. The main reason we have seasons is because the sun's angle of light on the earth. And that angle of light changes as the earth's tilt changes, as you'll see in the next diagram. So here, just a quick demonstration about light. So what I have is a piece of paper, a pencil, and a camping flashlight. So up here I'm going to divide my paper in half, okay, so you can kind of see. So I'm going to show you what indirect sunlight looks like. So when our earth is tilted away from the sun, this is kind of what we get. So here we get this sunlight beam, and what I'm going to do is I'm going to draw just kind of around that light beam here. And you'll notice too, it's not very intense. Okay, so the light isn't very intense there. So this is what happens. It's not direct light. It gets scattered about. When we're pointed towards the sun, this is what happens over here. You see, it's very intense. So it's more concentrated. There's less area that light is focused on, and it's more intense. So if you look at comparison of area of that light, remember this, it's the same amount of light coming from the flashlight, but it's very different in terms of area. Over here, that light is scattered much more over a larger area, and over here it's scattered not as much, kind of more concentrated in one central location, and it's brighter. So this is the kind of light we would get in the summer, and this is the kind of light we'd get in the winter. And in between, you'd find your fall and your spring light. So to think about seasons, you have to think, we have the sun in the center of our system here. Okay, your sun. Okay, make a smiley face. Everyone needs that right about now. Remember, the earth is tilted. Okay, and as it goes around the sun, that tilt never really changes. Okay, the distance really here doesn't matter. Okay, but we can draw our earth tilted at these 4 points. These 4 points will represent our 4 seasons. So as we think about our earth going counterclockwise around the sun, this would represent, this whole revolution around the sun would represent an entire earth year, okay, 365 days. So if we think about where we are in the northern hemisphere, we're right here, okay? We are right here, and so on. So right here, this really demonstrates the winter and the summer really well. If we put a point in the middle of the earth here and draw a line from our location in that point towards the sun, we're pointed very closely towards the sun, okay? Over on the opposite side, if we draw that line
and where we are in the northern hemisphere, we're pointed away from the sun. Okay? So here, this would represent our summer solstice. This is the point where we get the most amount of sunlight, or the most direct sunlight. Okay, we also have our longest days here. Okay, this would represent the winter solstice, shortest amount of day here. So as we move into summer here, you're going to notice that we're experiencing more and more daylight. Every day we add about 2 minutes of daylight onto our day. Okay, and then if we think about what's in between the winter and the summer solstice, well, we're going from winter to summer right now, maybe not fast enough or as fast as you'd like. Okay, but we have what we call our vernal or spring equinox here. And equal daytime and nighttime here, about 12 hours of daytime, 12 hours of nighttime. And then down here we have our fall or autumnal equinox. Okay, so these are about 3 months apart. If we think about dividing our year apart, the time span between each event here is about 3 months. Okay, so that's kind of the reason, or what we would draw in terms of a diagram for how we would get those seasons. So remember over here, the summer solstice is what we get, that very, very direct sunlight over here. That winter solstice kind of looks like this, is scattered about a larger area because we're pointed away from the sun. So opposite the northern hemisphere, so when we're having our winter solstice, the southern hemisphere is experiencing their summer solstice, and so on over here. When we're experiencing our summer solstice, the southern hemisphere is experiencing their winter solstice. So the seasons are kind of opposite as you travel across the equator.
So now that you've learned about seasons today, I hope you really, really, truly understand that it's not about our distance from the earth, or distance from the sun. I hope we're on earth. But really, it's all about the amount of direct sunlight that we receive in our area. It has nothing to do with the distance between the sun and the earth. Okay? Have an awesome weekend. Get outside, do something fun and exciting. Of course, practicing social distancing so that we all stay healthy. Take care.